All right, 3.1, number 3. And on number 3, it says the average rate of change of f of x equals 3x squared minus 2 from 2 to 4. The average rate of change is just the slope. What is, and so we find the points from the beginning to the end. So at 2, f of 2, which would be 3 times 2 squared minus 2. 4 times 3 is 12, minus 2 is 10. So I have the point when x is 2, y is 10. Then f of 4 is 3 times 4 squared minus 2. 16, 48 minus 2 is 46. So I get 446. And the average rate of change is just the slope. How much does it change as it moves along? So it goes 10 to 46, which is 36, and 2 to 4, which is 2, so its average rate of change is 18 for every one. That's the average rate of change. That was 3, now we'll do 33. 33, we have a picture of two lines crossing and they intersect at -4, 6, and this one is g of x and this one is f of x, and it asks solve when does the y value for what x is the y value of f equal to the y value of g. Well, they're both the same height, same y value at -4. That's the solution for there. And then b, when is the y value of f of x, f greater than g? So for what x's will f be greater, higher, bigger y value than g? Well, f is bigger than g over here for all the x's less than -4. Okay? And if I wanted to write solution set, I could do that. Okay, and now we'll do next one, 36. A very similar problem. We have two lines and a line crossing, and this is h of x. This is f of x, the one crossing, and the other horizontal one is g of x. And it says solve for f of x equal g of x, which means the y value of f is the same as the y value of g. For what x? Well, they meet right there, which was 7, -8. G and f both are -8 at when x is 7. Then the next one, when is g of x smaller than f of x smaller than or equal to h of x? And this point here, just for your information, was -4, 7. So when is g below f? Well, g is above f here. G, the y values of g are less than f for all of these. No, g here is lower than f, and f is below h up until here, and then it gets above it, so it would be just these in here. So x has got to be between -4 and 7, and it can be equal to h, so we can include the -4 and up to, but not including the 7. Now you could have done those in interval 2 notation too, but that one in interval notation. Anyway. Okay, that's 36. Next one's 39. 39 supply demand, find the equilibrium price. The supply is based on a price is negative 600 plus 50p. Demand, depending on price, is 1200 minus 25p. And so we want to know what price creates a supply and a demand that are equal. And so we set these equal. Negative 600 plus 50p equals 1200 minus 25p. I'll add 25p to both sides and 600 to both sides, so I get 75p equals 1800. Divide by 75, and p is, let's see, 75, 153, 300. There's 6 300s in there. 2 for everyone, so that's 12. I think that works out to be. Price should be 12 bucks. Check that. I don't want to give you wrong information here. 1800 divided by 75. Nope, 24. I got it wrong. 24. Okay. I didn't double it enough. Okay. So that's part A for 39. Part B, determine the prices which which quantity demanded is greater than supplied. If that's equal at 24 and the demand goes down and we want the quantity demanded is greater, so it would be less, would be the greater demand. So when the price B, if P was less than $24, there'd be a greater demand and less supply. What do you think will eventually happen if the price of t-shirts, if the quantity demanded is greater than the quantity supplied? If the price is lowered, so the demand is less than the supply, then people at that lower price will be willing to pay extra, or there'll be a black market develop or something that will push the price back up to the equilibrium point. That's what a free market is based on, is that the supply and demand will self-regulate. They will go to the same place. Okay, and then we have 40. And this one's going to be pretty much the same thing. Supply, in this case it's of hot dogs, and demand, supply is negative 2,000 plus 3,000 times the price, and demand is 1,200 minus 1,000p. So if we're trying to find the equilibrium, we would set these equal. Minus 2,000 plus 3,000p equals 1,200 minus 1,000p. So I'd add 1,000p to both sides. Add 2,000 to both sides. Divide by 4,000. So 32 over 40, which is 4/5 or 0.8. Since it's the price, 4/5 of a dollar or 80 cents. Okay, so that would be the equilibrium price. B, determine the price at which the quantity demanded is less. That would be for any higher price, there'd be less demand. So this is A. B, if the price was greater than 0.8 of a dollar, 80 cents, then the demand would go down. What do you think would eventually happen if the price of a hot dog's quantity demanded was less? If there was a less demand than there was of supply, then the surplus ones would have to be sold cheaper eventually. They'd drop the price just to get rid of the ones that they already made, and therefore the price would then head back towards the equilibrium again. Again, the idea of how the free market works. Okay, next is, and we're almost done here, 42. Luxury tax on Major League Baseball. T of P is 0.50 times P minus 189. This is standing for 189 million. And if they had more than that, then they had to pay luxury tax. What is the implied domain of this linear function? Well, the amount they pay the players is P. So it must be at least 189 million. Or greater. So P is greater than or equal to 189 million. That would be in the implied domain. Okay? Under that, there wouldn't be any tax. Otherwise, it's 50% of whatever that goes over that amount. And what is the luxury tax for the Yankees that had a 203? So you'd put 203.4 in here, and you'd figure out how many millions in luxury tax they would have. That's pretty simple, so I won't do that one for you. Let's see, 44. 44 said find the break-even point if the revenue was 12x and the cost was 10x plus 1500. So there must be a $15,000 setup fee and $10 per unit times the number of units you make. That's the cost of making something. And your revenue, you get $2 for $12, excuse me, for each one you make. So how many do you have to make to break even? Because you have to spend all that money to set up, and that's kind of what's going on here. So you set 12x equal to 10x plus 1500. Subtract 10x. I mean 15,000, excuse me. That was 15,000, yes. So then divide by 2 and you get x equals 7,500. That's not dollars. You'd have to produce 7,500 units to finally make the cost match the amount of money you get back in, and then you have to produce more to actually make your profit. That was 44, and then 45. It says straight line depreciation. You buy a new computer for $3,000, and you do it over 3 years. So each year loses a third of its cost, so it's going to go down by 1,000. So the model would be, the value would, after X years, would be $3,000 minus $1,000 times the number of years, because it's going to go down in 3 years, a third of that cost. So what is the implied domain? So that would be from 0 to 3. And C, graph the linear function, so it would cross at 3,000 and reach 0 after 3 years. That's the value, and you would only graph this much because you don't care about that. And what is the book value of the computer after 2 years? Well, it'd be 3,000 minus 2,000, which is 1,000. And E. When will the computer have a book value of $2,000? After 1 year. They'll take 1,000 off and it'll be worth 2,000. Okay, and that's it.